Today's notes are on inequalities. The first thing we need to look at is the four inequality symbols. The first one is less than. There's also less than or equal to, greater than, and greater than or equal to. The solution of your inequality is going to be a value or values that make your inequality true. A compound inequality combines two inequalities with the word and or the word or. Your graph of an inequality in one variable consists of all points on a number line with that correspond to solutions of the inequality. Let's scroll down and look at the examples below. The first thing we need to do is simplify this equation. We're going to do that by distributing 2 to both terms inside the parentheses. This will give us negative 5x plus 9 is less than or equal to 2x minus 12. I then want to move the x's to one side and the constants to the other, so I'm going to subtract 2 from both sides to get negative 7x plus 9 is less than or equal to negative 12. Next, I want to move the 9 over, which means I'm going to subtract 9 from both sides to get negative 7x is less than or equal to negative 21. Finally, to get x by itself, we want to divide both sides by negative 7. For this, we need to remember that when you multiply or divide by a negative number, you need to flip the inequality sign. That means that I'm really going to get x is greater than or equal to 3. This is my solution. I now need to graph this on a number line. So we're going to draw in a number line. And I'm just going to add some tick marks here. We also need to remember that if I'm looking at greater than or less than, on my number line I'm using an open circle. But if I have greater than or equal to or less than or equal to, we're going to use a closed circle. So for our example, because it's greater than or equal to 3, I'm going to draw a closed circle at 3, and I'm going to shade all values that are greater than 3. So I have my solution and I have the graph. Next, let's look at example 8. Again, the first thing we want to do is get x by itself, so I'm going to subtract 3 from both sides. Then I'm going to divide both sides by negative 2 to get x by itself, keeping in mind that because I'm dividing by negative, my sign's going to flip. We find that x is greater than or equal to negative 1. I once again want to draw in a number line so that we can graph this. And I'm going to add some points. I want to make sure that negative 1 gets added to my number line because it's part of my solution. And because it's greater than or equal to, I'm once again going to be using a closed circle. Because it's greater than, our arrow is pointing to the right. If it was less than, it would point to the left. Please try example 7 and example 9 on your own. The next thing we will be looking at is compound and compound or inequalities. For compound and inequalities, this occurs whenever we're using less than symbols. And you'll see the compound inequality written as one long inequality with two inequality symbols in between. In order to solve the inequality, I want x to be by itself in the middle. So I'm going to divide my inequality into three sections here, trying to get x by itself in the middle. So the first thing I want to do is get rid of that 1, which means I'm going to subtract 1. If I do it in the middle, I also need to do it on the other two sides. So I'll be left with negative 2 is less than negative 3x which is less than 9. Next, I'm going to divide by negative 3. That way x will be by itself. Oops. This should be a negative 3 on the step above. Make sure you correct that. Negative 3 divided by negative 3 is 1. Because I divided by a negative number, my inequality sign flips. X is now by itself. 9 divided by negative 3 is negative 3. So my compound inequality is 1 is greater than x, which is greater than negative 3. Next, we want to graph this, so we're going to move to our number line. And I want to make sure as I'm labeling it, I get all of those values on here. So I'm going to start with negative 3 and count up to 1. Because this is greater than and not greater than or equal to, our graph is going to be represented with open circles on both points. In this case, they're the same. That will not always be the case. It is possible to have a greater than and a greater than or equal to. Then we need to look at the expression. The first part says x is greater than negative 3. So I know that when I'm at negative 3, my values are all greater than it. If I look at the first part of the inequality and I read it backwards, x is less than 1, which means that x is going to be pointed to the left. You can also remember that for and inequalities, the area in between is what is always shaded. Please pause the video and try number 11 on your own. Then scroll down and look at example number 10. Example number 12 is a compound or inequality. For compound or inequalities, you solve each inequality separately and then graph them on the same line. So I'm going to use the first one and solve for x by first adding 5 to both sides, and then dividing by 2. I do not need to flip the sign because I did not divide by a negative number. I'm then going to go through and solve the inequality on the right. So I'm going to move the negative 3 over by adding 3 to both sides and then dividing by 2. We find that x is less than 2 or x is greater than 3. Both parts make up your solution, and you should separate them with the word or. Next, we want to graph our function. So we're going to draw our number line here. And I'm going to add just a few points to it. X is less than or equal to 2. Because it's less than or equal to, I have a closed circle. And I'm going to shade towards values that are less than 2. for x is greater than or equal to 3, again I'm going to have a closed circle, but they're values that are greater than 3, so I'm going to shade to the right. Just like compound and inequalities always shade in between, compound or inequalities should always be pointed in the opposite direction. Please try example 13 on your own. We will go over it tomorrow in class. For the examples that I asked you to try on your own, if you're unable to figure out how to graph them or you're confused, try to at least simplify the inequality and solve for the variable.